Good morning. I want to present you a project which deals with landslides, and we try using artificial intelligence to collect and select information about landslides on Twitter. This project involves three teams: the Euromed Seismological Center, the Qatar Computing Research Institute, and the landslide team of the British Geological Survey. This project was initially focused on earthquake-triggered landslides, and it also proved to be of interest for landslides per se, and the British Geological Survey is also now interested to use it to improve the way they harvest information about landslides on social network. Why did we focus initially on earthquake-triggered landslides? First, because we are the Euromed Seismological Center, but more seriously because they can contribute to the impact of earthquakes. So hopefully it is pretty rare, but in some cases landslides can significantly contribute to the global impact of an earthquake. It was the case here in 1970 during the magnitude 7.9 Peru earthquake, which triggered a glacier avalanche in the Huascaran region, and it flattened a city, causing the death of up to 30,000 casualties. Hopefully this is not very often, but what happens very often is that landslides block roads, and by blocking roads they can significantly hamper rescue operations. And here you have basically two cases. When it is a major road which is blocked, like on the left, the information may come out pretty rapidly. It is unlikely to be the case when it is a small landslides blocking a small road like on the right, simply because the number of people is not like earthquakes. If you don't see the landslides, you are very unlikely to be aware of it. So there are very few eyewitnesses of landslides, and then the information may not come out very rapidly. So what do we do currently for assessing the possibility of earthquake-triggered landslides? So the USGS produce probabilistic maps of both landslides and liquefaction, so taking into account the level of shaking, the expected level of shaking, the topography, the level of humidity. So it is very useful, but it will not, as I said, tell you whether there is a small landslide on a given road. I take the example here of the Nepal earthquake in 2015 to show you the type of information one can find or not find on Twitter for landslides. You may remember that this earthquake, which caused 9,000 casualties, also triggered an avalanche which hit the Everest base camp. On the left, that's the two first tweets published on this avalanche. You see they were published on the day of the earthquake, very rapidly after the quake, and they were widely shared. I did this when preparing this talk. I make a search to find the first tweets using the keyword landslides in Nepali and to see when it was published. This is the one on the right. It was published 3 days after the quake, and you see it was not retweeted. And it was exactly the case we are interested to find out. That's the case when you have landslides blocking roads and creating traffic jams. So this is clearly what we see, and what we see is that a small landslide does not attract a lot of attention. It is very different to try to detect earthquake and landslides on Twitter. Earthquake can be felt at large distances. They are rapid onset events. So when you look at the number of tweets in California containing the keyword earthquake, like here on the left, you see that the number increased extremely fast after the quake, the red line, and large volume. When you look on the right, this is the number of tweets of a very long period, and during 6 hours window. The red curves is the one containing the keyword landslides. And you see basically it is very small. It is 5 tweets a minute maximum, even when you monitor 31 languages. So basically you cannot detect the earthquake, so you are basically looking for a needle in a haystack when you deal about landslides. This is why we need artificial intelligence, and this is why we have been using a platform called Artificial Intelligence for Disaster Reduction, which was developed by Qatar Computing Research Institutes. It collects tweets. You make some selections, so like on keywords, on hashtags, etc., etc. You train the artificial intelligence, and the intelligence will select among these tweets and classify them as an output. So the principle is very simple, but we benefit from a large experience from the QCRIJ, which has been using this platform for a number of years now. So as I said, we monitor the keywords in 31 languages, and to give you an idea, for the first period we studied, we had nearly 500,000 picks, so the tweets with picks, and only less than 1%, 3,700, were related to landslides. One part of the job, and the huge part of the job, has been to train the system, so which was done by MSc and by BGS. BGS also brought its database of pictures to further train the system, and you see during the different version of the system, we increase its accuracy. It is higher now. I don't remember the exact number now, but I will show you how it works now on actual examples. So this is a picture where the prediction is more than 99% of landslides, and on the right you see where the system focused to make its prediction. So here it is a right prediction of the landslides. But what is more tricky is to make sure it is not landslides. Here is an example. You see, it may not be easy to say it's not a landslide automatically, but now the system performs very well on this type of examples. Another case on a beach, which is far more tricky, and again the system predicts it's not a landslide by 100%. So now the performances are very good due to this different version of training we have been carried out over the last couple of years. So now, if we look at how many tweets are selected by the artificial intelligence system, you see that basically we reach a maximum of 60 tweets per period of 6 hours. So it is basically an average maximum of 0.1 tweets a minute. So we are really looking at a low number of tweets, publication, but as I said, they can be absolutely essential. Here it is to show you the results for an actual earthquake, 7.4 in Mexico, and 6 hours after the quake, we collected these 3 pictures related to a small rock slides, basically, which blocked the road, which is exactly what we want to find after earthquakes and share with the people in charge of the rescues. 2 articles are currently in preparation. We will also deal with the geolocation of tweets, which is a general issue, but which is dealt with many people in the IT sectors. And we aim at having 2 separate services at the end of the project. One for earthquake-triggered landslides, as I said, for rescue operations mainly. And the second one is clearly illustrated by the need of the BGS, which is currently documenting earthquake by making manual harvest on social media, and which will use this service for making this process more efficient. Thank you for your attention.